Okay, for this next tutorial, I'm going to walk you through the basics of the HVAC dashboard in Chhaya. So, till now, we've talked about the passive analysis that Chhaya does, whereby it tells you when your building's overheating and getting too cold in the passive sense of the term. What we're going to do now is we're going to look at what happens when you have an HVAC system and how the shading affects your HVAC system sizing. So firstly, I'm just going to do a 30 by 30 cube. And what we're going to do is we're actually going to assume a part of the building that is attached to a larger building. So it's got just one or maybe two exposed surfaces. So I'm going to go over to the HVAC dashboard. And what you'll see with this, and this is basically set up for a laboratory thermal analysis, but it could be used for any building. So what you'll see over here is a graph with air changes per hour on one side, on the y-axis, and equipment and skin watts per square foot on the x-axis. And you have a line, a red line going across it, and a red dot in somewhere in the middle of it. I'll explain all of that. On this side, you have, so basically the red line is a denotation of when your air changes, the cooling effect of the air changes from your HVAC system is balanced by the heating effect of the equipment and skin loads. So what determines that slope is, well, the first one is the room height. So you can set your room height over here. And as I increase my room height, the cooling effect of the air increases because you've got more air per air change. And so that affects the the slope of that line. The room area is static, and it basically links the dimensions that I put forth in the other window. The delta T, which is the supply air temperature difference, and this defaults to 20, but you can change that. So as I increase the supply air temperature, the cooling effect of the air increases, and so you see the dot goes above the line. So basically, if the dot is above the line, you're actually overcooling the space. If the dot is below the line, you're undercooling the space, and you need additional cooling. So I'm going to put it back at 20. The square feet, the number of people in the room, square feet per person, affects it, and lighting power density also affects it. So you can play around with each of these. On this, on the bottom over here, you've got air changes per hour and equipment loads. So as I change this around, so let's say I make this, 7 air changes. So as I move that around, you can see the dot moves around over there. So the more air changes I move through the space, the more cooling is going to happen. And at some point, you see this thing triggers and it says reheat. And so what that means is I'm going to end up spending money on reheat. So when I go below it, it says I need supplemental cooling by this much. So I'm going to leave it at 6 air changes, which is your standard laboratory or patient room in a hospital. And then you can play around with your equipment your equipment loads. I'll make it about 3 or 4 just to start off with. But we have labs that go even further than that. And then over here, I've got a window that actually sets the total linear feet of hoods. So it defaults to 6 feet, which is 1/6 per foot. But I can play around with it. And as I go up, you see over here, it actually triggers a thing that says fume hood driven, and now I actually have 10.5 air changes, and that's driven by the exhaust from the fume hoods. I can change the operating sash height over there, and that'll actually increase the thing. I can reduce the face velocity, so I can say, okay, this is a low flow hood, and it goes back to a lower number. So I'm going to actually take out the hoods for now and just look at where the dot is right now. So let's assume we've got a 6 air change lab over there, and right now we actually have something that's pretty balanced with the equipment and the skin loads, so we're kind of satisfying our needs. You can play around with, so the P over here means we're looking at peak conditions in terms of skin, and you can also look at average conditions. So there's not that much difference right now because we've got shades. So one of the things that's really useful is you can look at an east facade relative to a south facade, relative to a west facade. And you can see the west is slightly hotter over here. So I'm just going to look at the south facade. So what this does is it looks at only the south. And then I can go over here and say, well, what if I remove the shades on there? What would happen? So when I take out those shades, it actually kicks on over. And with that same building, to meet that thermal load, now I would need to go up to almost 8 air changes per hour. So that's the cooling effect that your shades are having. And that's a directly translatable phenomenon for your building. And you can play around with that, you know, relative to different facades. So, for instance, on your west facade, if I take that out, you know, it actually has an even larger effect. You need to go up to about 9. So that's in essence the HVAC dashboard. And I hope you guys find it useful for doing some analysis. Thanks.